Hello, friends. And I've got to say, aren't magnets cool? Hey, check out my cart of science. Watch how I can make it move without even touching it. Woo, look at that. It's a non-contact force. Magnets can attract or magnets can repel. It depends on the poles of a magnet. That's right, I said poles. Every magnet has a north and south pole. Now, I'm not sure which is which, but on this magnet, the ends are the poles. On these little disc magnets, the sides are the poles. So let's take a look at poles of a magnet. Hey, just to let you know, it's kind of like the poles of the Earth. Look, friends, this model of the Earth called a globe has a north pole on top and a south pole on the bottom. Did you know there's an invisible magnetic field surrounding the Earth? And it's attracted, the magnetic field's attracted to the north and attracted again to the south. That's why a compass, which is something we use that uses a magnet, points north here in the northern hemisphere. Let's take a closer look at magnets and their poles. Woo! Hey, I can kind of show that invisible magnetic field by taking this cow magnet, which is a very strong magnet, and putting it into these iron filings. If I move the iron filings around a little bit, I can see that they stick to the poles. You can see that this magnet has a north and south pole. That's where the iron filings are sticking the most. All magnets have a north and south pole. Hey, some are even labeled. Look at these two bar magnets. Now, these bar magnets have letters right on them. This one is north and south. This one also has N for north, S for south. Hey, what happens then if I try to put the two south poles together? Watch. I will slowly push south to south. See what the other magnet does. Oh, it doesn't like it. It repelled. Let me try that again. South and south are like poles. They're the same. And it pushes away. Interesting. What if I turn it around? What about south and north? These are unlike or opposite poles. Let me try this now. South to north. And it attracts. We are discovering something here. Let me try north to north. Now I will try both north poles pushed together. North to north and dun dun dun, they repel. So we're finding out that like poles repel. Unlike poles like north and south, they attract. Isn't that cool about magnets? That's a rule. Like poles repel, unlike or opposite poles attract. Yeah! Magnets are awesome. I'll show you a trick in a little while. Hey friends, what an adventure studying non-contact forces like magnetism. Hey, just remember friends, like poles repel, like north and north or south and south, and opposite poles or unlike poles attract, like north and south or south and north. Think about that. It just makes sense. Now for a magnetic magic trick. So make that paper clip fly in the air. You can see it sitting on the tabletop now. Let's see if we can do it. Notice I've taped the paper clip onto the handle of this cart. What will happen now if I take a magnet, or better yet, two magnets, and I attract the paper clip to the magnets. Now watch as I slowly pull away. Can you see the paper clip floating in the air? Dun, dun, dun. Look at that. It's floating in the air. Now I can't go too far, can I? If I go too far, the paper clip falls. That is amazing. And I wonder if I did all of these magnets together, could I get further away? Let's try it now. Did I increase the force? Wow, I can get a little further away with more magnets now. Friends, this is amazing. It looks like the paperclip is suspended in midair. Did you know there's actually magic tricks where magicians use magnetism to make things look like they're floating? Amazing. Science is amazing!